Welcome to my channel. In the last episode, we said that the Cambrian explosion of life was not so sudden, or it was neither explosive. It took 50 million years for the Cambrian fauna to establish themselves. In this episode, we are going to look at the Ediacaran milieu. You know already how important it is to have a better resolution of the late Proterozoic milieu, since the strata of the time show the presence of ichnofossils or the trace fossils. These are complex tubular trails of the mobile, multicellular, burrowing organism that lived during what is recognized as the Ediacaran period, 638 to 540 GA, that is billion years, also called as the Vendian period. The upper limit of the Neo-Proterozoic era, which is the youngest division of the Proterozoic era, say beginning 1,000 million years ago, has been chronometrically extended up to 540 million years. This was based on the identification of these trails of biota observed in a sequence in the Ediacara Hill in southern Australia. It is interesting that the Ediacaran sequences are chiefly carbonate rocks which underlie the strata containing the Cambrian fossil. Why interesting? Because the sediments have fixed the carbon dioxide content of the atmosphere. The Ediacaran sequences possess all the lithological characteristics of sediments deposited during a marine transgression. The rifting of the continental blocks and the marine transgression happened towards the end of the Neoproterozoic glacial epochs that had covered the entire supercontinent Rodinia, say 1.1 GA to 0.9 GA. The rifting of the different continental blocks from this supercontinent Rodinia was obviously consequent to the vigorous convection current in the upper mantle of the earth. It opened rift basins in geographically distant regions and was accompanied by profuse extrusive volcanic activity, say about 900 to 600 million years ago. Such sequences of Ediacaran period have been identified on the rift margins of the Congo basins of Africa, Brazil, Newfoundland, South Asia, and Australia, and have been correlated with each other as they overlie lithologically the sequences of poorly sorted diamectite or trillites. The diamectite or trillites, as you know them, are deposited by glacial melting and downslope movement of terrigenous matter. Overlying the Ediacaran strata are the sequences containing Cambrian fossils, like the trilobite. The stratigraphic boundary marks the end of the Proterozoic era and the beginning of the Phanerozoic era. It is chronometrically dated at 540 million years ago, referred to also as the Precambrian-Cambrian boundary. The mobile multicellular organisms of the Ediacaran period lived for nearly 96 million years. They coexisted with the surviving bacteria and blue-green algae capable of photosynthesis. And they themselves evolved, overcoming the adverse tectonic changes and climatic ups and downs during this time span. But the Ediacaran biota seem to have vanished, as no ichnofossils of the time coexist with the Cambrian skeleton-forming and shelled fossils. One can therefore infer that the Ediacaran biota that predated the Cambrian period did not or could not survive the new milieu, which was adopted and adapted by the younger, more versatile Cambrian fauna. It seems acceptable or reliable to form an opinion that perhaps the newly evolving Cambrian creatures drew their biological energy and strength by preying on these multicellular organisms while they established themselves gradually. Paleobiologists have yet to link how the Ediacaran biota gave rise to the Cambrian fossil. That linkage should benefit the exobiologists immensely, isn't it? Tubular trails, much different than those of the Ediacaran, reappear, however, in strata younger than the Cambrian. We will look further into the Proterozoic era in the next episode. Thank you.